Hello, everyone. In this video, we're going to talk about expressions, the language of math. I know some of you have difficulty in solving math word problems, but to solve word problems, it really consists of two components, two important steps. The first step is translate a word problem from English to expressions, the language of math. And often the word problem talks about certain relationships, mostly in equalities. So then you have equations to work with. And the second step of solving a word problem, a difficult word problem, is solve those equations. Now, in this lecture, we're going to introduce expressions, the language of math. So what is an expression? Let's first look at an example. Example of a very simple word problem. It says that we have, let's say, Tom and Alex. The sum of their age the sum of their ages is 50. And the difference of their ages is 6. So in here, how we translate this English relationship into math? Well, it's actually pretty simple. If we assume M is Tom's age and N is Alex's age, then we have, for the first, sum of the ages is 50. That means the first one, it means M plus N equals 50. And the difference of their age is 6. That means M minus N equals 6. So we have two equations and two variables, and we're ready to solve them, right? But in here, the most important thing for the focus of this class is about how we translate the English into expressions. So what is an expression? An expression is a combination of numbers and all variables. Using operators like plus, minus, multiplication, division, and so on and so forth, right? We can combine those numbers and variables together, and that's an expression. Now, what is a variable? I have to say a few words about what is a variable. Variable is like a placeholder. For example, like in this example, we don't know Tom's age, we don't know Alex's age. Actually, this is what are we trying to figure out, right? So we don't know them, but we can assume it has some value, and we just put a M and N as a placeholder to represent the Tom's age and Alex's age. And the numbers are those constants like 50 and 6. And we can combine variables with numbers. Let's say a variable is m. We can combine by m plus 5, right? Or m divided by 5, or m subtracted by 5, or m times 5. Now, when I do m times 5, this can be written as 5 times m, or we can omit the multiplication and just write as 5m. And this really says that this is 5 times m, or a different understanding is m plus m plus m, 5m multiplied, adding together. This is 5m. So this is an expression, right? All these are expressions. When we have expressions like 5m, there are two parts to it. There's the 5 is a constant, which we call a coefficient. And m is the variable part. And of course, we can combine more variables together as well. Like let's say we have mn, and m times n is also an expression. And so is 5 times m times n, or m squared plus n, and so on. You can combine all the variables together in any way you want, and that's an expression. So when we have expressions of with variables, we can talk about evaluating an expression. Let's say the expression, one expression is x squared plus 5. Now, you can imagine that what the English version of this, you can try to convert the math into English. In this, it will say, okay, a square of a number plus 5 is something, let's say. So then you write as an expression is x squared. If you assume the number is x, then x squared plus 5 is the expression for a square of a number plus 5 is this, right? And for this expression, we can evaluate it for any x. Actually, if you plug in different x values and you plot this x squared plus 5, you actually will get a curve. So let's see. When x equals 0, this x squared plus 5, I'm going to put here, x equals 0, this will be 5 because you plug in x equals 0, so 0 times 0 plus 5 equals 5. X equals 1, and 1 squared plus 5, this will be 6. X equals 2, this will be 2 squared plus 5 will be 9. And x can be -1, right? Can be any number. X equals -1, it will be 6 as well. So this function, if you plot those for different x, if I just like put the x here and the 1 and -1 this, and if I plot the different values, you will see something like this, like more look like this. And of course, we're not there yet, but just want to give you a flavor of, we can plot for different x, the valuation of this expression. Okay, let's look at another expression, the variation of that. How about a expression of x, y plus 3? Now, this has two variables. So to evaluate this expression, we have to know what is x and what is y. So for example, let's x equals 1 and y equals 1. Then you plug in this expression equals 4. When x equals 2, y equals 1, this will be equals 5, and so on and so forth. So given an expression, if you have values for each of the variable, we can evaluate. And that's kind of the key of an equations. For example, if I have x squared plus 5 equals 2x plus 6, for different x, we can evaluate this, and we also can evaluate this. To find the value x satisfy both, it means that when I plug x both right hand side and left hand side, the value should be the same. And that determines that there's only going to be few limited number of x's is going to make this equation satisfy. And that is really solving the expression and ultimately solving the word problem.